Right, hello guys. Oh, I haven't done the green screen today. I'll do that in a minute. All right. So where did we get to yesterday? Hopefully that was right with you watching the video. My hiccups have now subsided. So I feel like yesterday then we got. Ooh, did we finish it? What did we get up to this? That's interesting. I thought there was more left to do, but if we finished it, then awesome. Um, Yeah, it looks like if we did that last question, question 10, which I think we got to in the stream, I think we're done. So let's do the register and then I'll figure out a change of plan for today then. So, right, attendance. So we've got Lucas, we've got Emily, Eliza, Amy, Oliver, Harry, Isla, Sally, you can't comment. Cool. Thanks, Emily. Ruben, and Finn. Cool, so just missing Tom and Ben then. All right. So yeah, I had planned to finish off this paper, but it looks like we did it yesterday. So that's good. Right. So the next thing we need to do is do some pure revision because that's one mechanics and stats paper. I think if we get through one pure paper, then I'd like to do some general kind of topic revision. Looking at modeling as a specific revision goal. So in terms then of a paper to do, I think let's have a look at 2018's pure paper 1 and then we'll look at 2018's pure paper 2. So I think I can add in so let's give that a go. Give me 2 seconds just to try and access all of this. Can I unzip? No. Okay. Interesting. It's gonna work. Pure paper 1, pure paper 2. Cool. Right. So let's just open these in Google. Oh. Oh dear. Right. Okay, yes, we're going to start working through this paper as soon as I can get this to load up. Just waiting for this app to load. Sorry, guys. It will be done in a sec. Hopefully, this is taking ages. How is everybody? Everybody doing well? Cool. All right. So new one of these, and we will load up the paper I just downloaded. I'm gonna guess it's this one. Yep, Pure Maths 2018 paper one. Good. Okay. Has anyone done this paper already? Because I don't want to redo this if you guys have already done this one. I can find a less popular, well-known one. But let me know in the chat if you have, and I'll think of something else. But for now, let's just get started with this. So it's 3 marks. I'll give you guys 3 minutes to get stuck in. It's been a while since we've done any pure, so please comment if you do need any help. And yeah, we'll go through this one in 3 minutes time. Why are you tired, Lucas? Any of you guys been surfing a bit? Every day, I am jealous. I haven't gone in ages. I've been climbing in my garage, but yeah, I do miss a bit of surfing. Yeah, maybe I'll have a look. I don't know. I just think Nuki will be really busy, and yeah. If I can find somewhere sheltered with no crowds, then yes. But yeah, I don't fancy going out with tons of people. Right, let's do this then. So, 8/3, Oliver. I think that might be it. Let's have a look though. So, a theta is small, okay, and measured in radians. Use a small angle approximation on this. So, quick reminder: sine of theta approximates to theta. Cos of theta approximates to 1 minus theta squared over 2, and tan also goes to theta, though we didn't. I still haven't put the green screen up. Tan of theta goes to theta as well. So I'm going to change the top there to 1 minus cos of 4 theta will turn into 1 minus 4 theta all squared over 2. Over 2 theta stays the same. Sine 3 theta is going to turn into 3 theta. So we just need to simplify this. So we're going to get 1 minus all this stuff. So 1 minus 1 cancels. So we get 16 theta squared over 2, which is going to be 8 theta squared. Over 2 theta times 3 theta is going to be 6 theta squared, which gives us 8 over 6, which gives us 4 over 3. Nice. So, yeah, Oliver and Lucas, spot on there. Cool. Anyone got any questions about this one? Nope. All right, let's move on. Ah, not all set up yet. So differentiation. What we got? 3, 4, 5, 7 marks here. Looks all right to me. Can you guys give this a go? 7 marks, 7 minutes, and see how you do. Comment your answers when you got them, or if you need help. Cool. Right, let's do this. All right. So part A, differentiate it. So nothing weird here. So if we rewrite this, y equals x squared minus 2x minus 24 x to the half, so it's ready to differentiate. So dy dx is going to be 2x minus 2 minus 12x to the minus half. Second derivative is going to be 2 plus 6 x to the minus 3 over 2. Verify the stationary point when x is 4. Stationary point is when the gradient is 0, so we put x is 4 into dy dx. 2 lots of 4, take 2, take 12 lots of 4 to the minus half, so that's going to be 8. Take 2, take 12 over 2, which equals 0, therefore stationary. And part C, determine the nature of the stationary point. That's when we use the second derivative. So we're going to put 4 into d2y by dx squared. Giving us 2 plus 6 lots of 4 to the minus 3 over 2. And I don't even need to do this. That's going to be positive. 2 plus something, that's a positive number. So I'm just going to say that's greater than 0. Therefore, minimum. Cool. Everyone right with that? So you can be a bit lazy with that. I mean, you could work it out. It's not that hard, but don't need to. Cool. Right. That wasn't too bad. Next one is some trig sector segment radian stuff. Looks right though. It's a 4 marker. Shouldn't be too taxing. So 4 mins on the clock. Starting from now. Give it a go. Cool. Let's do this one. So you guys got Route 33. Cool. It'd be nice to get some more comments from some more people. So let's do this. So we got area of the sector is 11. So remember the sector equation is half r squared theta. And the perimeter is 4 times the arc length. So arc length L equals r theta. We want to try and find the value of r. Okay, cool. So we're going to set up two equations for this one. One for the area, one for the perimeter. So perimeter of this thing is going to be 2r plus the arc length r theta. Cool. And that is meant to be, the perimeter is 4 times the length of the arc AB. So that's going to be 4 times r theta. So I can simplify this to get 2r equals 3r theta. And I can find theta, if I divide by r, is going to be 2/3. Alright, so I can put that into my area equation at the top, and we can say 11 equals half r squared theta. Theta is 2/3. So in other words, r squared is 11 times 3, which is 33. So r is root 33. So nicely done there, Lucas and Oliver. Cool. Right, let's get some more responses on the next one, please, guys. I'd like to see what everybody else thinks. Who else was here today? So could I get a comment back from, let's have this time, Finn and Eliza? Could you guys give me some sort of comment after this next question? So next one on the list is a is it parametric? No, this is iteration. This should be pretty, oops, didn't mean to delete it. Let's do that again. There you go. Hopefully you guys can see that. So yeah, Finn and Eliza, can you guys, everyone do it, but Finn and Eliza, can you guys give me some answers this time? See how we go on. 4 minutes should be alright, but we'll go until we get a response from those guys. So hopefully they're still here. Right, 4 minutes. Give it a go. Right. How did Finn and Eliza get on? Any answers, guys? Please comment if you did. First part, do integrate it. What are we trying to do? Show the no. We want to put in 3, put in 4, and show that the roots. Because this is all numerical methods. So we're going to put 3 in as x, put 4 in as x, and show that there's a change of sign um, when those equations are set equal to each other. So if we said 2 ln 8 to take x equals x, put it all on one side. 2 ln 8 minus x is 0. We're going to sub them both into this equation. So we're going to do f of 3 would be 2 ln 8 take 3 is 5 minus 3 and work out what that is. So on the calculator, type it all in. So 2 ln 5 take 3. Let's make sure I bracketed it properly. Yep, get 0.2188. Going to do the same thing with 4. So f of 4, 2 ln 8 take 4 is 4 minus 4. And we get minus 1.227. So then we say change the sign. Therefore, root in the interval 3 to 4. Run out of space there. 3 to 4. Cool. Right. Then they told us to use the iteration formula to determine whether we can find an approximation for alpha. All right. So, and we can kind of look at it in terms of a cobweb diagram, or I think we can actually use it. So you got two choices here. You could do cobweb, or you could type in your values. So cobweb diagram, we're going to start with 4, then go to the line, curve, line, curve, line. So it looks like it will work there. But let's find out by doing it numerically. So we're going to use x1 is 4. So if we put 4 in, we get 2 ln of 4, which gives me 2.77. Okay, so x2 is 2.77, which seems right because we go up to there and then over to there, and then the x value there is probably 2.77. So then we do 2 ln of our answer and get 2.0395. Okay, and keep going. If we keep going, it quite quickly falls to pieces. So no, this isn't going to work. It's actually diverged quite spectacularly there. So we end up getting 0.7. What do we get? So I'll write them all down. x4, 1.425. x5, 0.71. x6, minus 0.67. And you can't learn a negative, so then it breaks. Cool. Interesting. Right, so yeah, no, it would not work. No. The root diverges. Cool. Right. Next one, guys. Let's just add it in. So 5 mark trig differentiation. This time, let's have let's go for Ruben and Isla. Could you guys try and answer this one for me? So 5 minutes on the clock, starting from now. Cool. Right, let's go for this. I just want to we'll go back and look at that last in a minute because apparently it does. It's meant to converge, and my spider diagram did show it converging. So yeah, we'll try and see what's going on. Is a three? No, I don't know. Let's find out. Okay, so we want to differentiate this thing, which looks lovely, doesn't it? Okay, so we got quotient rule. So u is 3 sine theta, v is 2 sine theta plus 2 cos theta. Sorry guys. Yeah, we'll do this. We're going to go back and look at the other one in a sec. So du dx is going to be 3 cos theta. dv dx is going to be 2 cos theta minus 2 sine theta. So remember the equation for the equation for quotient rule is v du dx minus u dv dx over v squared. So we get 2 sine theta plus 2 cos theta times by 3 cos theta. Take away u dv dx, so 3 sine theta 2 cos theta minus 2 sine theta all over v squared. Like that. This is going to require some simplifying in it. So let's make some space. Right, so we're going to expand all this. So we're going to get 6 sine theta cos theta plus 6 cos squared theta minus 6 sine theta cos theta plus 6 sine squared theta over, should I expand this one? Yeah, why not? 4 cos squared theta minus 4 sine theta cos theta. Is that going to be 4 or is that going to be 8? Yeah, that'll be 8 because we've got 2 sets of brackets plus 4 sine squared theta. Is v on the bottom not v dash? Did I do v dash? Damn it, it is. Did I write v dash? That's terrible. Sorry guys. It should be v on the bottom. I'm sure I wrote that right in my equation, but yeah, okay. Well spotted, Oliver. God, that is bad. You tell I haven't done any pure in a few weeks. 2 sine theta plus 2 cos theta. Square it. So we're still going to expand it, so we get 4 sine squared plus 8 sine theta cos theta plus 4 cos squared theta. Alright, so let's get rid of this and work our way through this. So on top, we've got sine squared plus cos squared, which is 1. We've got 6 of them, so we're going to get 6 on the top. The other bit cancels, so we are left with just 6 on top. On the bottom, we're going to get 4, because we've got sine squared plus cos squared, which is 1, and we've got 4 of them, so we get 4 on the bottom. Plus, here's a double angle for sine, so we're going to call this 4 sine 2 theta. If I divide the tops and the bottoms by 4, we're going to get 3 over 2 over 1 plus sine 2 theta. So you guys were right who said 3 over 2. So Ale, not quite there. Have a look for your workings. And then Lucas, yeah, you're the first one to get the correct answer there, so well done. Didn't square the bottom right. Yeah, easily done. Cool. All right, I just want to go back and look at this again because I just checked this because I found it weird that my spider diagram, my cobweb diagram, said there was going to be a root, whereas when we did it, that looks like it completely converges to a root. So, huh. And the mark scheme says, what does the mark scheme say? Says it can be used because this cobweb spirals inwards. Yeah, I agree with that, but why didn't it work? So it should work really. Let's give this a go. See if you guys can spot anything I'm doing wrong. So let's get the calculator up. All right, so I type it in. What have we got? So our answer is, so our first one is 4. So we'll just hit 4, save it as my answer. So we want to do 2, learn, brackets, 8, take. I think I typed this in wrong, you know. I think I did 2 learn of answer, maybe. Anyway, let's see. 2.7, 3.3, 3 point. Yeah, this is definitely different, and it is indeed working. Yes, I don't know what I did before. At least I drew it right. So main thing that all they wanted in the mark scheme was to draw it right and say it converges. So cobweb converges. So yes, if you wanted to do it, you can do it, and you'd still get the marks for that. Right. Anyway, so back to next question. So for this one, I would like to hear from uh, Emily, Amy, and Harry. So could you guys comment something on this one if you're out there? Give it a go. Don't mind if you don't get it right, but just show me some work and show me some stuff that you've done. So we've got a 10-mark question here, mainly coordinate geometry. So we'll see how this goes down. So 10 marks, 10 minutes, starting from now. All right, cool. No, I don't be mean to Harry. Just sorry, I just missed all this chat. Cool. So it sounds like both of you got it. Let's. Which part was that for? That was part B. So cool. Right, let's do this. Yeah, part C is an interesting one. Okay, so we need to find a tangent at the point P. We got the circle there. Um, cool. My brain's not working today. Um, circle. Blah blah blah. There's our circle. So we need an equation for that later. We've got a line here, L, is a tangent at the point P. So an equation of the line P to A is that. So if we um okay, yep, cool. Right, that took me a while too long. So we've got the equation of the tangent. We know the center of the circle is point A, so therefore we need the perpendicular line. We need the negative reciprocal of 2. So our gradient is going to be minus a half. And then we're going to use the center point, so we're going to say y minus 5 is minus a half, x takes 7. And rearrange this. If I times it all by 2, 2y minus 10 is minus x plus 7. Add 10 to the other side. 2y is, add it, let's just rearrange it down to what they've got. 2y plus x equals 17. There we are, cool. Right, next bit, find an equation for the circle. Cool. So we want to work out the length of line, need to work out the radius. Okay, so if we work out where these two lines meet, that's going to be our point P, and then we can find the length of A to P, that's going to be our radius. So if we put those together, we're going to get two lots of 2x plus 1 plus x equals 17. So that looks a bit like 117 there. It should just be 17. So expand that. 4x plus 2 plus x is 17. So 5x is 15. So x equals 3. Put x back into either of these. We get y is going to be 2 times 3. So y is going to be 7. Cool. So that's our point A. No, it's not. That's point P. P. So if you find the length of line between P and A, that's our radius. So, doesn't, oh yeah, cool. All right, so we're going to do y2 take y1, so 7 take 5 squared plus 3 take 7 squared, square root it. So that gives us the square root of 4 plus 16, so root 20. So our radius is root 20, which you guys agree with. And if we put it all back together, it's going to get some space up here. We're going to get x take 7 squared plus y take 5 squared equals radius squared, which is 20, which you guys both got there. Cool. All right, nice. Part C then, find the constant k. This is where it gets a bit more difficult. So we got another line, which is also a tangent. Okay, if it's a tangent, it meets it in one place, so it meets once. So in other words, if you solve them together, the equation you get will only have one set of solutions and one set of roots. So it's going to be a discriminant question. We know b squared minus 4ac is going to equal 0. So if I sub these together to solve them, we're going to get x let's sub it all together first. X takes 7 squared plus, instead of y, I'm going to put 2x plus k equals 20. We're going to expand all this and then do the discriminant on it. So again, need a bit more space. So x squared minus 14x plus 49 plus, this is a bit difficult to expand. Yeah, these are always a pain in the neck. Just trying to think if there's an easy way around this. Probably not. All right, so I'm going to expand this as kind of 2 bits. So I'm going to expand this bit first, and then we'll expand that in a minute. So we're going to get 2x plus k times 5. Wait, let's do that better than that. So 49 squared. So we're going to get 2x plus k all squared plus 2x plus k times minus 5. And we're going to get 2 of those because we've got 2 brackets. And then we're going to get plus 25 for the 5 squared. And that should equal 20. So we've expanded all that. Let's simplify it. So x squared minus 14x plus 49 plus 4x squared plus 2x times k is going to be 2kx. And we can have 2 of those, so 4kx plus k squared. Then we're going to get 2 times minus 5 times this bracket, so it's going to be minus 10 times that, which is going to give us minus 20x, and then minus 10k plus 25 equals 20. Cool. All right, everything's expanded. We just need to simplify. So we're going to get, how many x squareds have we got? Well, we got 1 there, 4, we got 1 there, 5. So we're going to have 5x squared. X's, we've got minus 20 and minus 14. So minus 34x. We've also got kx here, so I'm going to write that next, so it's next to this. So plus 4kx. And then all the rest of this stuff is number, so for the end. So we're going to put k squared plus k squared minus 10k. And then we've got 29, 25, 49. If I take the 20 over, I think that's going to leave us with 54, so plus 54. Oops. Cool. So there's my equation. So I need to do the discriminant on this, and it doesn't look like a quadratic, but believe me, it is. So the a term is going to be 5. The b stuff is all here, so we need to take out a factor of x, but that's b, and the number on the end is all going to be c. This does seem a bit harsh for 3 marks, but we'll keep going with it. Yeah, I'm going to check if there's a easier way to do this in a minute. There might be. Don't know. Well, look. This will work though. So b squared minus 4ac. So b is going to be 4k. Well, let's write it down. A is 5. B is going to be 4k minus 34. And c is going to be k squared minus 10k plus 54. So all that's left is to actually do the discriminant on this. I hope I haven't made any mistakes. I hope you guys have been checking, because I'm doing this quite fast and a lot of it in my head. But we'll see. So b squared minus 4ac equals 0. So b squared, this is still going to be a pain in the neck to expand. It's 4k minus 34 squared minus 4 lots of a times c, and c is k squared. Well, that's hopeful, at least if we've got the same numbers. Minus 10k plus 54 should be equal to 0. I don't really want to do this, but I suppose I have to. That's my job, isn't it? Let me clear the screen on my calculator. So you got 4 times 4 is 16k squared. 34 times 4, 136. Gonna have two of those. So we've got minus 272k. And 34 squared is 1156. If this was in an exam, I would be doubting my work here. So we got 20 times everything in here. So we got minus 20k squared. 20 times 10 is going to be plus 200k. And 20 times 54 is 1080. So minus, ooh, yes, plus this minus 1080. Okay, so this is going to simplify a bit now. So let's turn it into a single for each term quadratic. So we get minus 4k squared minus 72k plus 76. That doesn't look too bad. Maybe it divides by 4. I think it does. Oh, I said that fast. Does it divide by 4? Yeah, I think all this will divide by 4. It does. It does, guys. It absolutely does. Nice. Okay, so we got minus k squared um, minus 18k plus 19. I think we get 19 and 1. Got a feeling about this. So we got k squared plus 18k minus 19 equals 0. It's going to work. K is not equal to 1, so that kind of fits as well. We've done it right. I will check if there's another way, because that seems tight for 3 marks. But yeah, I guess you can do a lot on the calculator. So, let's factorize manual style. So we're going to get K. I think we need a minus 19. No, we don't. We need a minus 18. Minus 18. And then minus 1. So added together they'll make minus 19, times together they'll make plus 18. So K is 1, or K is 18. K is not 1, it said we couldn't have that, so K must be 18. Alright, I bet there's a way we can do this with differentiation or something, because that seems incredibly tight. Nope. Nope, that's horrible. You could use vectors. Doesn't seem any nicer. Yeah, that is. I guess the rest of the test have been pretty fair so far, but that 3 marks for that. Come on. But yeah, that's what they. Wait, K is minus 19. Hang on. Have I done something stupid in my last couple steps? Have I actually solved that wrong? Yeah, it should be minus 19. Have I done something stupid here? Oh yeah, I have. I've been an idiot. Sorry guys, that should be a minus. That should be plus 19. Because I can't factorize after a few weeks off of normal maths. Yes, so forget that. Minus 19. Oh, yeah, of course it is, because minus 19 take 1 is 18, and 19 times minus 1. Oh, I got my times and divide wrong. Oops. Oh well, there you go. So, k is 1 or k is minus 19. It can't be 1, so it must be minus 19. Cool. How are we doing? 15 minutes. Let's see what the next question is like. That looks alright. 7 marks, 7 minutes. Yeah. Okay, this time could I have some comments from anybody? I've asked all of you. Ruben, I haven't seen anything from you or Eliza today. Or Amy, have you commented? No. If you guys are still there, can you please do some of this one. But yeah, we'll go through this in 7 minutes time. So 7 minutes on the clock. Starting now. Cool. Have fun. If it's independent of K, it won't have a K in the answer. Yeah, put your limits in and you'll find it cancels out. Cool. Right, let's do it. So first one, we've got to integrate this. So we're going to get 2/3 ln 3x take k. Yeah. And put the limits in. So we've got k and 3k. And we get 2/3 ln of, what will that be? 9k minus k. Take 2/3 ln 3k minus k. Alright, so that's going to give us 2/3 ln, and then maybe we can divide these. So we've got 8k over 2k, which is going to leave us with 4. So we get 2/3 ln 4, which is independent of k. Right, part B, show that this is inversely proportional to k. Cool. Right, so the way we integrate this one is using negative powers. So we've got 2 lots of 2x take k to minus 2. So power is going to go up. So we're going to try 2x take k to the minus 1. But we'd need that 2 up front, and if we differentiate that, we're going to get, actually that kind of works, doesn't it? Differentiate this one. We get minus down the front, so we do need a negative sign. 2 would come out, and yeah, we'd get that. So that's what we get for our integral. So put limits on there, k and 2k. So we get minus 4k minus k is going to be 3k. And then plus, because it's minus minus, 1 over 2 lots of k is 2k, take 1 is k. So we get that. So it's 1 over 3k plus 1 over k, which is going to give us 2/3, 2 over 3k, which is inversely proportional to k, because k is on the bottom. So inversely proportional to k, because k, yeah, as I said, is the denominator. Cool. Everyone right with those? So we got to, all right, where we got to, so this is group E. And we'll try and finish off this paper on Friday. And then, as I said, next week we might look at some specific topics to revise, because going through papers is kind of dull. I'm getting bored of it. So we'll keep doing for papers for the rest of this week. And then first thing I want to do next week is talk about modeling and cover all the types of modeling. And then maybe we'll look at stuff like integration and I don't know, whatever else you guys want. If there are topics you guys want me to go through, email me what those are, and we'll look at actual revision lessons on those topics so that we've covered it in a bit more detail than just looking at past papers. Cool. Make sure your assignments are going up on Moodle. Otherwise, I'll speak to you guys on Friday. Cheers. Bye.